Recording is started. That wasn't so loud. Well, hey everybody. Welcome to week 2 of Advanced Programming with Java here at Portland State University. Thanks for coming back. I hope everybody had a good week. I really appreciate all the questions that folks asked on Slack, the emails you sent me. I met with a couple people in person, or not in person, but had a quick Zoom call and stuff. I hope everybody is ready for some more. There was a lot last week, certainly during class, that to follow up on. But I'm seeing lots of people who have run the survey program, who have shared their GitHub repositories with me. Appreciate that. That'll help me help you we as we make our way through the term. So I just wanted to start off with kind of a preview of what we're going to see tonight. We got lots of good stuff. And we're going to start out with Prime Minister's questions. This is a Q&A that I always do to start off class. Any questions that remain at the end of the week, here we are talking about Project 1 or the cones or testing or the Java APIs, the things you've been learning about. This is a great time to talk about all those things. I also made a couple of notes of things that we can cover. And then I want to spend the most of tonight talking about testing. We saw a tiny little bit of how to write a unit test and how to do a red-green test-driven development cycle last week, but that was just dipping our toe in the water. I want to arm you all with some tools for doing test-driven development, for writing both unit and integration tests for your projects, and so we'll be doing that tonight. It'll be a combination of a group activity and then watching me implement some unit tests and some integration tests. Along the way, we're also going to talk about Project 2, which is assigned tonight, and then also talk about continuous integration and how GitHub Actions can do that for you. So lots of good stuff. I expect that will go until 9:10 tonight. But I hope it gives you the additional context that you need to really dive into your projects and not only write the code, but also write the tests that'll validate that your code's doing the right thing. But to start us off with, Prime Minister's questions. So what can I tell you about the projects, about the classwork, any of the content, things like that? Oh, it looks like a couple of questions came in on chat, and so I'll start with those, and then feel free to raise your hand either in class or on Zoom if you've got another question. The first one is, do we need unit tests for the airline class? I've not seen any file for that unit test section. The answer is yes, you need unit tests. I can't remember if there is an airline test that is created out, off the bat, airline. Nope, there isn't an airline test. You will need to add one. Well, or really, we'll talk about this in detail, but every class in your every main class, so in this case airline, has to have some test coverage for it. Now, whether that happens in a dedicated airline test or whether it just is exercised by other code, I don't really care. But we will see that there are some code coverage requirements, which is a percentage of the overall code, and then every class has to have at least one test. Let's see here. In a some other great questions here. In a DM to me, someone asked, will we talk about pom.xml files in more detail at some point in this term? They're covered in what I think is quite a lot of detail in the Maven lecture, which was on last week's lectures. So I encourage you to, if you want to know more about Maven and more about what POM does, you can do that. As a matter of fact, once we're done with all your questions, there was a topic related to resolving some of those Maven warnings and errors that people saw that I wanted to cover, so that you can clean up your projects if you so choose. But no, I'm not going to, I will of course respond to questions and stuff, but I wasn't planning on really diving into pom.xml configuration very deeply. And that's just because while yes, you're using Maven, and I sort of want you to understand what the POM is all about, I don't want you to write POMs yourself. I'll provide all of that for you, and then you can and then use it. You shouldn't have to modify it very much. There are a couple of places will help where you can. It's optional to modify it, so you can do things like generate nice reports and get rid of some of the warnings and stuff. You don't have to. Oh, great. Okay, question about the test, which is README can be read as a resource. Can we save this one until we talk about the README? So we are going to talk about the README. Oh, I don't know, in the middle of midway through class. I think it'll be much more meaningful to talk about that test and what it's doing. But I'm really glad that you mentioned that because that's something that is a little different, a little advanced that often trips people up. Let's see what we got. Oh yeah, and then Kristen asked about the upstream repo with Git. Yeah, that's something else I was going to cover too. But what else? Okay. There were a couple of things that came up during the week that I wanted to talk about. Let's see here. And the first one is a number of people commented, that they were surprised when IntelliJ was kind of barking at them about some of the errors that occur in their Maven projects. You're right. You see IntelliJ, it's like got a Maven plugin and it's underlined in red, and red is bad, and so then something wrong has happened, and what should you do? I feel IntelliJ is being a little dramatic about the severity of these things. So the bottom line is that if you can run, a Maven W clean verify, and your build passes, you're good to go. Now IntelliJ tries to be helpful and may tell you about there's some things about your project that are surprising or may indicate a problem. And if on your first day of class, your first week of class, seeing that can be startling. But I want to let you know if you're seeing those kinds of things, don't worry. As long as your Maven project builds fine, that's okay. That being said, I want to take a moment to explore some of those things here to show you how you can get rid of that. Just be more confident that your Maven project is configured correctly. Let's see here. The first thing, I can't show it to you because I've downloaded my Maven plugins already, but I think it was over, I can't remember if it was on the Maven tab or if it was in the problems section or something. Some people sent some screenshots about it saying that, hey, this plugin doesn't exist or this plugin isn't available. That's because the code for the plugin hasn't been downloaded yet, probably because you haven't performed a Maven operation that downloads that plugin. So some of the plugins are for generating reports and actually generating a website for your project, and you can do that by I think I mentioned it in project 1 assignment. You can generate that site by running the Maven site phase. So let's see here. So there you go. I don't want to go into super detail. I will save this for next week because it's really cool, but I don't want to take the time to go into it. But if you run Maven W site, that will look at your code and generate a bunch of reports, like your API documentation and things like that. Oh, Clara, I see your text or your message. We'll get back to that shortly. Yeah, I'll answer your question in a minute when I'm finished with this. It'll generate a site for you, and do all this analysis, and all those analysis tools and things like that are in separate Maven plugins that will all get downloaded. So if you run Maven site, it'll download all the plugins. If you then synchronize your IntelliJ with your projects on disk, which you can do with your Maven files on disk, which you can do by going to the Maven tab over here on the right, and then clicking reload all Maven projects, everything should get synchronized up. And I think those errors should go away. Those warnings should go away. So that's one category of Maven foo-foos that we saw this week. The other one is an error like this one right here, complaining about like the parent.relative path of the POM for a given project doesn't line up basically. and that's true. So here is the pom.xml file for the student project, and the project tag here is underlined in red because it's saying that the parent doesn't match the parent project isn't the project that is defined in the parent directory. So if we look on disk, oops, important state Java winter 2023. There's a pom.xml file here in the top level directory. And this is the parent POM for, this is the top level POM, we'll call it that. It's a top level POM for your projects. We'll see in class tonight why this is really a good thing, but we looked a little bit at it last week, and we saw that this POM file defines a module for each one of, well, it defines a module for the student, the Cohens, and the airline. And this thing you can do in Maven. You can have, your project can have a parent, and then a POM can have submodules. And what this error is, what this is complaining about is that they don't line up, because the parent here, so each Maven project has a group ID. It has an artifact name, so the name of the project, and it has a version. This is how you identify a Maven project, right? It's a part of some group. It's a particular artifact in that group, and there's a version of it. And when a project references parent, it does the same thing. So the parent of the top level pom.xml is actually my top level pom.xml, which the name of the artifact is CS410J, and then it's got this group ID, and it's got this version. The versions happen to be the same. So this is what the parent one is, the Portland State Java Winter 2023. The reason that IntelliJ is complaining about this is because when we generate the project, the script that generates the project, the Maven archetype that is used to generate the project, it generates the student project, but then it says the parent is my CS410J. And so basically what it's doing is it's skipping a level in order to fix the, and so because what IntelliJ expects, IntelliJ expects that the parent of the student project is the pom.xml file in its parent directory, which is, and actually maybe I'll go show that here. I'll go show that here. So here's the student POM. IntelliJ expects that the parent of this POM is the top level one, and its group ID. Again, the group ID of this project is this thing. Oops, sorry, too many windows. I'll close Maven. I'm going to here my student. I want its parent to be not. Oops. Not my, it'll be your user ID, and then it'll be whatever you called your, I don't have that, copy it. It'll then be this artifact ID right here, and then that, and still complaining about it? Oh, let me just reload it and see what's happening there. And it looks like it's happier now. Good. So the whole idea here is that this is a warning that Maven gives you because the pom.xml sort of hierarchy doesn't match the directory hierarchy. Again, a minor thing, but if you like to keep things extra clean, you can make that change there. I believe the student project, does it have the same problem? Oh, that was the student project. How about airline? Airline's parent, yep, once again is mine. So then we can go back up here and copy this thing again and apply it to airline, and we'll be happy there. Anyway, so I mean, if you want to clean this up, you can. I'm pretty sure there are instructions in the README for the repository here that talk about this. Yeah, it's in this "How do I use the parent POM" section. So if you want to explore it more, you can read all about it here. But again, this is a warning. These are warnings that I suppose you probably see it when you execute Maven on the command line and IntelliJ complains about it. But these are not. This is not anything that ought to get in your way. If you are seeing problems, let me know, because I would not expect these things to actually cause things to fail. Just that IntelliJ was real friendly about it. I think those are the two Maven things that I wanted to talk about. Are there any other Maven questions before we get to Clara's question? Clara, would you like to ask a question now?
Sure. I was just going to ask about the java.comments and student.java, but I think we're just going to talk about documentation in general today. So
yes,
I'll just wait until then.
Yep, thanks. Yeah, we'll talk about the java.comments. Yeah, like I said, halfway, maybe a little bit later, probably 3/4 of the way through class. Yeah, and we'll show how all that works. Let me commit these changes. And so then let's do a couple warnings. Okay. I also wanted to talk about upstream repositories. Let's see here. Right. So you created your GitHub repository from a template, from my template repository, and this is the first time I'm using templates. And one of the things I'm not sure about, we're going to experiment with it right now, is whether or not I can have the project created from the template be a downstream project from the original. The reason you want to do this is because, hey, let's say I find some bug in like the submit script, or I wanted to add something to the POM and have you all get it, or something like that. What I could do is make a change in the Getting Started repository, and if you've set the Getting Started repository as an upstream repository of your repository, then it's easy to flow code from my Getting Started repository down to yours. Now, when I've done this in the past, I haven't used a template. Instead, I had students make kind of a wonky copy of, not copy, I'd say derivative. It's not exactly a fork, not in the usual GitHub sense. They basically took my repository and made a special copy of it, but made it in a private GitHub repository so that so it was private, which is an important thing. But because it was actually a copy of the repository, it had all of my changes in it. The template repositories aren't. It's really just like, it's not a copy with history. It's just like, okay, take all the files and put them in a new repository, which I didn't realize when I decided to use a template for this term. So as a result, I'm not sure if this is going to work, but let's give it a try. So I have my checkout right here of my my repository. So I do git status, and there's nothing changed, right? Yeah, that's nice and clean. So I'm going to see what happens when I try to add the add an upstream repository. Okay, that worked. Now can I pull and merge the upstream changes? Oh, interesting. Merge conflict in pom.xml, automatic merge fail, fix conflicts, and then commit the result. Huh. Well, it's something both added pom.xml. Huh. I wonder what it thinks the conflict is then. Oh, interesting. Okay. So because I had made some local changes to my pom.xml, let's see here. So there's some. Okay, sorry. Git conflict. So for those of you who aren't familiar, one of the great things about Git is that it'll tell you when two people have worked on the same line of code and have basically conflicted and made changes. Now, Git is really good about resolving changes. It's super smart, but there's sometimes there's changes where it's like I don't know how where Git doesn't know how to do that, or you don't want Git trying to resolve it. I think here's a good example where it said, "Hey, you've made these changes. Actually, I've also made changes elsewhere." Oh no, not to the palm. I haven't. But I bet if I change your user ID, um, so I can resolve those changes pretty easily. Let me see if there's any place else that has. Oh yeah, also down here at the bottom, there's probably some white space difference or something like that. Okay, no big deal there. So anyway, so what I think I've done is by making this an upstream repository, now if I do make any changes to the getting started repository, I can easily flow them down into my winter 2023 repository. That's kind of neat. I'm gonna refresh to see the changes. It says, oh, good, it tells me what the conflicts are. I click resolve to see what it's like. It's like, okay, so IntelliJ is helping me resolve the conflicts, which is really nice. Let's merge. So this is merging conflicts. One of the probably one of the worst parts of software engineering. Oh boy, because basically what we're trying to do is like, hey, you've got changes that were made in the past, and now you need to reconcile them in the present. Which, if you didn't make those changes, it can be really hard to do because you don't have the context for when things have changed. This is why you want to merge code in early and often. So I want to keep the code on the left. I like this code here. And so I've resolved that conflict. And then it's F7 to go to the next conflict. Oh, here we are down here at the bottom. And boy, they showed up the same to me. I'll just keep the one on the, I'll keep this one. I will get rid of this one. Oh, and I will do that there. Okay, cool. Oops. Oh, and it's telling me, yeah, all conflicts have been, okay, been processed. Save changes and finish merging. Great. Okay. Oh, look, and it was nice enough to tell me that I had merge. Sorry, I had bad syntax in my pom.xml, which I did. I had those merge conflict lines in there. Now everything's happy. Okay. Do I need to? I don't have any local changes. Now, do I have anything else? Let's see here. Oh, all conflicts have been fixed, but you are still merging. Use git commit to conclude merge. Okay, and it's telling me that I merged, and so it put together a. Okay, I can tell it. I can say, yeah, go ahead and tell me that it's pom.xml was a conflict. That's cool. Good, and now I've merged that, and so now I can push that up to GitHub. And now, if I try to pull down changes again, what happens? Okay, it's happier now, which I think is good. Anyway, so maybe this does work. That's neat. And so now that I have this as an upstream repository, again, if I change something in getting started, I can pull it down to my winter 2022. This is an optional thing for you to do unless I find a bug in something in the getting started repository that I want to push down to everybody else, or rather that you need to pull down in order to do something like submit or to. Oh yeah, I didn't talk about submitting. I got to do that. Let's see here, project 2. I'll do that for submit. Sorry. Neat. Anyway, Kristen, I know that was kind of fast, and that was uh, maybe a little disjointed. Did that answer your question, though? So it's something that I think should work. And you tried it
Yeah.
out, right? Does that match your experience having that conflict and stuff?
Yeah, I had some weird conflict. I'll go back and see if I maybe entered some text wrong or something. So yeah.
Okay, cool. And yeah, and let me know if you like some help dealing with the conflict, because that's like I said, that's like this really icky part of working with Git and collaborating with others, is when two people change like the same code, and how do you put everything back together again?
Okay, thanks.
Yep, no problem. Sweet. Okay. Anything else for Prime Minister's questions? Okay. Let's dive into something. Um, so I've been thinking a lot about testing and how best to introduce testing in the class. We've been doing unit testing for like a very long time in this course, and um, because my experience has been is that most students haven't had much of a formal introduction to testing. I'm never sure what people know and what makes sense to people and what doesn't. So I'm trying something new this year, um, and having a more structured discussion around testing than I have in the past. So I'm going to post a handout here. I also put it on Slack for anybody who's listening to the recording. This is a document that I will that we'll use tonight to go through an activity of brainstorming, and then I'll implement test scenarios for the student program. So hopefully you remember the student program from last week. This is a simple project zero that helps make sure that we can get started. And really, it's the class that I use. It's the code that I use for test-driven development. And so we created the student project, and a number of you did also. And it comes with a student class that has a constructor and a couple of methods, and then a main method whose behavior is to, let's see here, yeah, like right here. You run the program and you give us command line arguments, and then it spits out the toString of the student object that it creates. Okay, and you can probably see some parallels between the student program and your project one. And so what I want to do now is spend some time exploring testing through the student program to help inform how you test your project one and actually all your projects after that. So I put together this little handout over the weekend. So I have a little bit of preamble, sort of talking about testing in general, and then what we'll do is we'll break into breakout rooms and brainstorm some test scenarios. So, testing, and actually just software in general. Software has some behavior, right? I mean, fundamentally, what software does is it takes some inputs and creates some outputs, right? I mean, if you really break it down, right? So the user interacts with your program in some way, and you take that input that they provide you, and you give them some output. One of the challenges that I've always found as a software developer, is figuring out and really expressing what the expected behavior should be. And so it comes down to expectations and how you express an expectation. And so then there's this really nice and very simple framework, if you will, to express expected behavior, and that is given, when, then. So when you're thinking about a particular scenario, how a piece of software should behave, there are three aspects to it. There is the initial context, sort of like what has happened before the thing that we expect to occur. And this is sort of like the setup. This is the given part, right? So given that we're in some situation, and then there is the behavior that you want to perform, right? The thing that you do. So when. So when the user provides this input or performs this action, all of a sudden the scenario, the interesting behavior, is occurred. And then there is the expected outcome. So like, hey, in this situation, given given these conditions, when I perform this operation, then I expect something to happen. And I found that this pattern is just very, very helpful for expressing any kind of expectation. yes, in software, but like also like with my kids, I'll do this where it's like, okay, you know, what did you expect to just happen? You know, given these things. Oh, okay, yeah, right. You know, just or you know, with coworkers and stuff, it's like, hey, we are, you know, someone is surprised by something that's happened. It's like, well, you know, tell me what you would have expected. And it's like, oh, okay, well, that's good to know. So, given when then. And so then when I think about the expectations I have for my software, I use this. I use this. And the nice thing about this capturing scenarios like this is that it's in plain language, right? These are sort of things that anybody, whether or not you can, you know, you are a programmer or not, can understand, which makes it actually clear to everybody. So the person who is asking for the behavior, we can understand the given when then. The person that has to implement it and the person that needs to validate it can all agree that yes is what it's supposed to do. And so this framework, or this pattern, I guess is probably a better word, this pattern of expressing behavior is popular enough that there are these tools like Cucumber and JBehave that allow someone to write scenarios that are pretty readable English. Pragati mentions that, Gherkin, the Gherkin language, which is, again, the given when then. I think that's what Cucumber is implements. You have these tools that can take these nice specifications that are pretty readable English and will actually execute them. And that's really cool. We're not going to cover that in this course. That's a little too much. Or at least I haven't figured out how to integrate it in with everything else that I'd like you to learn. But however, what we're going to do tonight is take these same scenarios, or given when then, and then implement them in JUnit using JUnit and Hamcrest. So those are the tools that we'll be using in this course. I, of course, didn't invent all of this. There are some really great resources. Dan Terhorst North is credited for really codifying given when then and popularizing that format as part of behavior-driven development. And I have some links here. I encourage you, if you want to do some more reading, if you're curious about this stuff, that's really good background. They're pretty short articles. Martin Fowler's also got some good stuff too. So really, when we talk about behavior scenarios, this is, I think, a really good way to get started. Any questions on that before we start taking the next step and start doing this stuff? Nope. Okay. So now let's break out into breakout rooms, and we're going to do the following. We're going to look at the student assignment and study it and sort of figure out what the requirements are. And then we're going to, each breakout room is going to brainstorm and capture some usage scenarios for the student class using this given when then format. Now, there are two aspects of the student class that we want to test, we want to validate. There is the sort of the student class itself, the class, the object. So it's like it's constructor and it says method and it's toString method, right? There's that part of the code. And if you're in an odd numbered breakout room, you'll be coming up with scenarios for that. Let's see what that looks like for a second. And in the even numbered breakout rooms, you'll focus more on the command line, which are the inputs on the command line and then outputs that are written to standard output or standard error. So you won't be concerned so much with like the details of the implementation. You'll be thinking more about like the user interface, for lack of a better term. But both of them are capable of expressing many, if not all, of the behaviors of the program. So we'll do that for 20 minutes. And the folks who are here in the room can work together, or if you want to join a breakout room on Zoom, you may. Then we'll reconvene and we'll walk through some of the scenarios. We'll talk about the experience that you all had. And then we'll begin implementing these scenarios. So the test scenarios for the student class will be implemented as unit tests. And so then the format for these given when then scenarios is that there are, you create a student, and each student is created with potentially different name, classes, GPA, and gender. Those are sort of the inputs of the student constructor. And then you'll do something with that student object, like invoke its toString method or invoke its says method or something else. And then it will produce some output or some result, I guess is a better word for it. So for instance, we, like last week, we implemented a test case that said, hey, it doesn't matter what what values are provided to the student constructor, as long as they're valid. Whenever you invoke the says method, then the result of that method is this class is too much work. So this is a given when and then, right? Given you created a student that with certain inputs, when you perform some operation on that student, then some result recurs. And if you're talking about the says and the toString method, then there's a value returned by that method. So if you are in an odd numbered breakout room, you'll be doing that. You'll choose what your breakout rooms are, but any questions about this particular this set of behaviors? And the intent here is that you populate the rows in the table. If we can get a 15, I think that's pretty good. Okay, so odd numbered breakout rooms are doing the student class. Even even numbered breakout rooms are talking more about the command line program itself. And so here, given when then, it's sometimes a little difficult to figure out what the exact things are. I said, well, given that, hey, we built the student executable jar, and now we can run from the command line. When you provide the following command line arguments, then the following is written to standard output or standard error, or something else happens. And actually, then the following maybe occurs, because you can do things like exit with error codes. Well, actually, you should probably always have something written to standard output and standard error. So this is the example from the assignment from the Project Zero. When you provide these command line arguments, then the following is written to standard output. All that kind of stuff. So any questions before we go into breakout rooms to brainstorm some scenarios for the student class and the student command line program? Sorry? Oh, I put it in, that's a good point, the link for people in the classroom. It's in Slack, it's on the general channel. It's my most recent post in the general channel. Yep. No problem. Yes. Okay then, I will open up the breakout rooms. So I'll pause the recording because who wants to watch me fiddle with breakout rooms? Okay, hey, so we just spent some time in breakout rooms talking about these test scenarios for talking about the test scenarios for the student program. Let's talk. I want to hear about your experiences doing this exercise. And so, if you were in an odd number breakout room and you talked about the constructor for the student class, actually the constructor and the methods of the student class, what did you experience? How did it go? What were things that were surprising? What things maybe met your expectations? And I forget, here in the room, did you work on the constructor? Or did you work on the main, or both? Both? Okay. Okay. Well, so you can weigh in too. But we'll start with people who are remote. What did you think? So let's see here. I guess odd number. So room one. If you were in room one, so Adam, Ben, Devin, Logan, Tanner, or Theo, what did you think? What helped? What hindered?
I thought it was good just to like think of like, what real user inputs would be, and then like what we would expect the system to output given those inputs.
Yeah, nice. Room three, what about your experiences? Were there any particular test cases that were maybe controversial, or maybe a scenario where you didn't really know what the expected behavior should be?
I do think that we had some questions towards the end about whether we should create test cases for like methods that we know have not been implemented yet, such as we know what says is supposed to say, but it throws that exception saying it hasn't been implemented yet. Should we set up our test scenario to catch those as well?
Great, yeah, that's a good topic of conversation.
Just one more thing to add there. There was one more thing that we saw that the GPA, there's no specification for the range in the student PDF. It just says it's just there. There is no check of that.
Nice. And folks in the room, so like, what were your experiences working on this? Yeah, so boundary conditions and like how to handle them. Yeah. Oh, well, you were thinking ahead to implementation. So like, yeah. Yeah. Okay, yeah. So realizing that, like when we're working on the main method, you might have sort of different logic, different expectations. It might be okay, or maybe that there are some case error situations that can happen with the main method that can't with the constructor because the GPA is a double, and so you already know that you've got a double as opposed to like on the command line, which is an equal string. Great. Yeah, yeah. Ah. Right, yeah, yeah, error messages and how to express them, yeah. Making it useful, yeah. Yep, yeah, figuring out the guardrails are, yeah, excellent, good. Okay, and let's see here, for the people that focused on the command line, so that was the even number of rooms. So if you were in room 2, so Cheng or Deepika, Michael, or Sabati, what were your experiences focusing on the user interface, on the command line inputs and then the outputs to standard error and standard output?
We were majorly focusing on the data type of the parameters that is expected from the command line. So we tried to cover, we were checking the others also were adding data types. So we checked for the, let's say the name to be a double. And we also checked if the name is adding like a first name as well as a last name. And then we have a list of classes. So how will we handle it? Like how will our class differentiate and not add the last name to the classes, because classes is an array of string. So we were just looking through the data type basically. Yeah, and personally, like I would have a question, like I see a lot of common parameters or let's say checks in the odd and even. So probably once you finish this, we can check, see where the right place is to check the data types of the inputs. Yeah.
Nice, excellent. Your observations. Let's see here, and there was room 5, room 6. Clara, Nail, okay. Shriyoshi and Zheng Mao. What were your experiences thinking about the command line interface?
Sure. One thing we thought about was when we're actually like writing out what errors are coming out to the screen, how technical those should be versus more helpful. Can't really guarantee that this is being used by like a programmer. So making a helpful message for them to fix their error without maybe confusing them with different terminology. And also, as we're like typing out these, you know, test inputs, what errors are easy for us to spot with our sweet little human eyes, but might be a lot more difficult to really pin down like realistically in code. If someone enters their first name as operating systems, everything else checks out. Realistically, are we ever going to be able to verify that operating systems is a valid human name? That raises disturbing questions like, what is a name? So that's a little harder.
Luckily, it's not a philosophy class. It's A name is a identifier consisting of letters and numbers.
Yeah,
Cool.
I guess
Excellent.
if we had like a batch of acceptable classes, then that would be easier to check.
Great. Great, thank you. Okay. Any other observations that people would like to share about this activity? Or questions that you still have remaining?
I guess one is just that you can be in a class and not have a GPA if it's the first class you're taking at the institution and whether the program allows you to do that. Or just that like the talking amongst peers allows you to think about the actual usage of the program. And yeah, like the name question, existential human questions and such.
Great. You know, I think in that case where you sort of want to ask somebody who maybe has a well, ultimately you'd like to ask your user, but I think probably the best thing to do is just to capture what your expectation is. Say, hey, listen, you know, yep, when my name's operating system, okay, this is the name of the person. And just being explicit about that. And that way, if someone looks at your scenarios and says, well, that's strange, you can have a conversation about it, as opposed to assuming what the behavior would be, because most likely someone will make a different assumption than you will. Nice. Okay, well, the next thing that we're going to do is we're going to implement some of these, but let's take a quick break first, because you know you've all been pretty focused and you might need a quick little brain. So let's just take 6 minutes. We'll come back at 6:45 and then we'll implement some of these. Okay, hope everybody enjoyed a quick little break. I had a chance to stretch their legs, hydrate, do whatever it is you need to do to focus while we start implementing some code. I'm just checking the chat. Okay, no one said anything to say. So at the beginning of class, we did some brainstorming to brainstorm some test scenarios for our student class and for our student program, for the command line program. Now what we're going to do is we're going to implement some of these test scenarios for the student class as unit tests in the project, and we're going to do that with IntelliJ. And so, actually, before we talk about all that, I did want to speak a little bit about the cycle of test-driven development. So I mentioned this last week, but now I want to go into more detail. So test-driven development, or TDD, is not necessarily natural for people, you know, especially as I think as software developers, we tend to want to focus a lot on the implementation. We're going to solve problems, right? This is what gets us excited, is what we like to do. But if you just focus on the implementation, you can get yourself in some situations that can be problematic. So for instance, you know, as you're adding more capabilities, more functionality, you make changes to your code to maybe support one scenario, and then you introduce a bug into another scenario. And you might not realize that right away. As a matter of fact, you might go days or weeks or months or a long time without realizing that a change has broken something. And once when you find out long after the fact, it's really hard to go back and figure out what change caused the actual bug. You might also find that you wrote some code and it doesn't really behave like you expect, which can be surprising and again hard. You know, the more code that you write the more code that you write and the longer you take to validate it, it's harder to figure out what code exactly was wrong. Similarly, as you're looking at your code and maybe you realize it's not as nice as it could be, or it's kind of hard to read, or that there's some duplication or something, you know, doing all the code refactoring, that might introduce a bug also. And again, if you don't validate those changes, then it's more likely that you won't realize that you made a mistake. And finally, you might just write a lot of code, just sort of thinking it's the right thing to do. I know I've made this mistake. I've written a bunch of code that I think will do the right thing, and after writing a lot of code, you find out, oh, it doesn't really work after all, or it doesn't work, or maybe it does work, but it doesn't do what was intended because you really didn't understand the problem that you were trying to solve. So, test-driven development is really about finding bugs early. And you want to find them early and you want to fix them early. And actually the ideal state is that you never write the bug in the first place. So how do you go about doing that? Well, that's why you write your test first. And you say, great, this is what I expect to happen. And of course, the first time you try it out, it won't work because you haven't implemented it yet. So the wrong thing will happen. But then you work to make it happen. So there are 3 simple rules that Uncle Bob Martin captured that I think make a really good foundation for test-driven development. So rule number 1, you are not allowed to write any production code. So this is the code that's under test, the main code. You're not allowed to write any production code unless it is to make a failing unit test pass, right? So this is kind of a mindset shift. The reason that you write code is to make a test pass. Okay. Rule number 2, you are not allowed to write any more of a unit test than is sufficient to fail. And compilation failures are failures. So the whole idea is that you make your unit tests minimal. You want just say, hey, there's one very specific thing that I want to test, and that's all you're going to write. And then the third rule is that you are not allowed to write any more production code than is sufficient to pass the one failing unit test. And this is something that I know that when I first started doing TDD was so hard for me, because it's like, I'm thinking 3 steps ahead, I'm so smart, I know everything. And you got to say, that's very nice, but have the discipline to just work in these tiny little increments. And when you do, what you'll be able to do is write higher quality code a lot faster and a lot more confidently, because you will have demonstrated that it works along the way, and you will have built up a suite of tests that you can keep running continuously, that will give you feedback on when you break something. So you strive to make your test pass. That's the ultimate assessment of your software. It also tells you when you're done. But anyway, I'll talk more about that later. So those are the rules. The way you put them into practice is by performing this red-green refactor development cycle. Oh, looks like there was a question. How would you recommend automating test generation? If you can automate tests for something, you can probably also automate the thing that you're writing. I suppose there's a school of thought that says, yep, just throw spaghetti at the wall and see what sticks. Okay, that's neat. That's boundary testing. That's not where I would start. I mean, because think about it, right? Like with your, with the student program, what do? Just throw a bunch of random numbers at that? You're not going to be able to go incrementally. So the thing with test-driven development is that it is a human-focused activity, and it's the human that thinks about the test and thinks about the implementation, and it's the humans that do all of that. You might find that eventually, yes, having and you did mean generation of tests automatically, right, as opposed to running the tests automatically, right? So that's what you're talking about, although I don't know, maybe ask your favorite AI, how to test my student project, see what it says. But anyway, so I wouldn't, honestly, but the input, variation of command line inputs. I'm guessing, here again, this is not something that I employ very often because I haven't found it to be a very good return on investment. In order to write a tool that generates inputs for your program, you have to understand what your program does. And other than maybe testing it at scale or really testing extreme boundary conditions, you can do that by hand. Like boundary conditions, like really big inputs, really small, inputs with just random characters. Yes, neat. But that's pretty much I wouldn't start there because the logic of your code hasn't been implemented. So it's good to think about those extremes, but you probably don't want to start with the extremes. You want to start with understanding, hey, what is my code supposed to be doing? So the red-green refactor development cycle. So the first thing that you do in the cycle is you write a failing test that is as simple as possible, but still useful, right? It does something that's meaningful, and that's the red part. So it's like I have the test, and it compiles, but it fails, and that's okay, right? You want to start off with demonstrating it's like, okay, I have a scenario and it hasn't been implemented yet, and it's important to run the failing test to make sure that your current code doesn't already implement that functionality. I've made this mistake where it's like, okay, you know, I wrote it and you know, I didn't bother running it, and I started making changes. I was like, oh, wait a second, no, it already works, and that signals to me that there's something that I don't understand. So either I don't understand what's currently implemented, or I don't, or more likely, there's a bug in the test. The test doesn't really express what I want it to. Once you have that red test, then your job is to make it pass. The way you make it pass is implement the production code, the code that's under test, to make the test pass, and do like the minimal amount of work, right? And so then again, resist the urge to like implement the whole thing and then write your test afterwards. It's not really what we're doing, because there will be flows and stuff. It's really hard to go back and figure out, well, how should I test this particular piece of code after the fact? It's much easier to say, well, I want this functionality, I'll make that work. I want this functionality, I'll make that work. And we'll see examples how to do this. And then once you have something passing, so I've implemented and so now my test pass, you take a step back and say, well, can I improve my code? And you know, for instance, can you improve the names of the variables, the methods that are being used, so that they have more clear intent? Do you have duplicate code that you can consolidate into one place? You know, you can make changes like this, sort of polishing things up so it's nice and understandable. Then, because you've built up a suite of tests, you can rerun those tests to see, to make sure that you haven't broken anything. And that's really powerful, because what you end up with at the end of the cycle is code that you validate that works, and is easy to work with in the future. And again, by doing this in lots of little steps along the way, when you get towards the end, and by the way, you're done when you can't think of any more failing tests to write. So when you think you've implemented all your functionality, and you verify that all of your functionality is implemented as expected, poof, you're done. And you've got a way to validate that release. So anyway, again, what TDD is all about is working in small steps to get there. And what you'll find is that you'll stop writing bugs, right? Your code like always works. Or if you do find that you've broken something, you'll learn about it right away and you'll fix it. So you know, and this is sort of the hidden return on investment with TDD, where people will say, "Oh, I'm spending all this time, you know, writing tests, and why am I writing all the tests?" Like, well, yeah, you're spending time writing tests instead of fixing bugs. And trust me, the tests are a lot easier to write than the bugs are to fix. Great. So anyway, so that's test-driven development. David, I appreciate you asking that question. Are there any other questions that people have about TDD, about how it works, about the red-green refactor? Nope. Okay. Before we start writing some code, I also want to talk about the difference between unit tests and integration tests. So TDD builds up this suite of tests that you use to validate your code. And because you want rapid feedback, it's really important that your unit tests can run really, really quickly. Now, for the code that we'll be writing in this class, your unit tests will probably run, you know, in under a couple of seconds, right? Even after you've like implemented your whole project, you know, the code base isn't so big that you're going to have slow running unit tests. But as things get bigger and bigger, and over time, it's really important to keep your unit tests nice and fast. So there's a category of tests that are not a good fit for unit tests. And these are ones that have external dependencies that are slow to access or take a long time to set up, which will ultimately slow down your automated tests or unit tests. So a unit test does not talk to the database. It doesn't communicate across the network. It doesn't work with a file system. It isn't dependent on other things being run at the same time. And it shouldn't require you to do special things to your environment, like set things up in a certain way in order to run it. They should be simple, and they should focus just on the code being run, not all of the external dependencies. However, there are times where you do need to talk with a database, where you do need to work with a file system. This is when you have what are called integration tests. And this is where it's not just a unit of program execution that you are working with. Instead, it's the integration of multiple units of program execution. And usually it's with objects that live outside of the process, or systems that live outside of the process. Again, like a database or a file system or a network or whatever. What we'll be seeing tonight is first we'll be writing a bunch of unit tests based on the first set of scenarios for the student class. And then we'll be writing integration tests for the command line. And these tests, because they are different and should be run at different times. Again, you run your unit tests all the time. You run your integration tests less frequently. We put them in different places. So like the student test will work with the student class. We'll create an instance and invoke its says method, invoke its toString method, things like that. The main method, on the other hand, does more complex things. It reads from the command line and interacts with with standard out and standard error. Now, if you want to test that functionality, because we wrote a whole bunch of scenarios for it, how are you going to do that? Right? How do you capture what was written to standard output in a way that you can validate that? Well, I wrote, and we'll see it a little bit. I wrote a framework that will let us do that. So then, and it's called invoke main test case. And what we'll be able to use that for then is implementing these these scenarios that you all captured, where you send some input to the program via the command line, and then something's written to standard output or something's written to standard error. So I know we haven't seen this yet, but any sort of fundamental questions about unit tests and integration tests and what they're used for? Nope. Okay. Well, let's get to it then. Now, I was looking over these test scenarios for the student class, and I was trying to figure out what would make some good unit tests for it. And there's actually a lot of great functionality that is being exercised here. Passing in unrecognized genders, negative GPA, things like that. Oh, and then you also have, let's see here, this one, which I'm pretty sure number 9 and number 2 look the same to me, maybe with different GPA. I don't know how meaningful that is. But anyway, this is all good stuff. And so what I'll do is I'll look through the list and I'll start implementing some of them. We might need to talk about whether or not the everything is what we expect, but let's start out with it. So let's see here. Let's go to IntelliJ. Close some of these windows. I like to do a split screen with the code under test on the left, and then on the right, I like to have the test that I'm writing. So I am going to split and right. So the test is over on the right. Refresh my image, sure. Okay, right now I have. These are the 2 tests that we looked at last week. I have this sort of tests the get name method to make sure that the name that we pass into the student constructor is equal to the name that we passed in. Okay, that's good. And we implemented this using test run development to say that all students say the same thing: this class is too much work. So the first thing I'm going to do is I'm going to run these tests just to make sure that all my code still compiles and that it behaves as I expect. Nice, and it does. Okay, now I'm going back to my test cases. And you know what, the first thing I'm going to do, I'm going to implement test case number 2 first. And here's why. I'm not going to implement it and then make it pass, because that would be the entire program. Instead, what I'm going to do is I'm going to implement it to give me an idea of how close I am to having this end functionality, sort of like this holistic end-to-end capability implemented. So I'm going to do that. So let's see here. So the first thing that you do when you write a test is that it starts with the @test annotation, which tells the JUnit test running framework that this is a unit test. And then I'm going to say Dave student says what is expected. And again, I like to have these big long method names that are very descriptive. So I'm going to create a student. I think I'm going to call it Dave. And let's see here. It's a new student. And the name is Dave. There, oops. Oh, but it has the electric curly quotes. Never mind. Dave. And oh, there's a question. We're not using hamcrest here, not seeing the is. We will use hamcrest in the assertion, but right now we are just setting up the code to be tested. Yep. Oh, and I tend not to use is. I just say, you know, I'll just call it equals to for equals method. Yeah, but the is method is another part of the hamcrest API. Sounds like you might be familiar with it. Let's see here, taking 3 classes, algorithms, operating systems in Java. So here I want to send in the classes. So I'm just going to create a variable called classes. Okay, and I can do that. I can use Alt-Enter to show the context action and say create local variables. Yep, there we go. Classes and then new array list. Wow, it's getting all sorts of suggestions. So the first class is algorithms. Classes.add algorithms. And so this is an array list. It's one of the collection classes that you learn about in the lecture for this week. Operating systems. Systems and Java. So those are the classes that Dave takes. The GPA is 3.64, and the gender is male. So that's I'm setting up. As a matter of fact, sorry, one more thing. Did I talk about act assert? No, I didn't. What is that called? There's beyond given when then. There's another way to set up. There's another sort of way to describe unit test. Arrange, act, assert. So it's like the first thing that you do is that you arrange the data to be tested, the objects to be tested. That's what I'm doing here. I'm arranging that. I'll just even sort of call it out. Oops. Arrange, which is kind of like given. And then act when. And so the act is basically what I says. Actually, let's call it Dave says. Not Dave says, sorry, it's the Dave 2 string. And then the assert, which is the then. And here's where I want to use a hamcrest API. I want to say assert that, not Dave string, Dave string. Dave string equal to, and then this whole thing here. That's a lot. Okay. So this is an example of a unit test, right? The first thing that you do is you create some code that's going to be some objects that will be tested. And so I created a Dave student. Then I perform an action on that. So I get its toString. And then I make some assertion about it. It's like this is where I codify my expectation. So I expect that the string that's returned by Dave.toString is equal to this big old thing. And so now I'm going to run this. Now I fail spectacularly, but who knows? Maybe it's going to magically work. Okay, great. It's saying that when I invoke, so what happened was I ran the test, and the test encountered an unsupported operation exception saying not implemented yet. And I talked about last week, you get the stack trace. And so IntelliJ allows you to navigate into it. So on line 42 of student.java, well, sure enough, when I invoke the toString method, it throws unsupported operation exception not implemented yet. Okay, well, that's where I am right now. I'm not terribly surprised. But you know what? I've got this test here. And what I'll do periodically is come back to this test and say, hey, are you passing yet? How close are you to passing? Because that's ultimately what I want to get. But one more thing. So I have this test. It's nice that I have this test, but I don't want to run it all the time. when I, like for instance, as I develop my student, I want to be able to run all of the tests in my student test class and not have to worry about this one failing. So what I'm going to do is I'm going to say at ignore, sorry, it's not called ignore, what is it called now? Disabled? Yeah, disabled. I'm going to say, hey, this test is not abled, it's disabled. And so now when I run all of my tests, that is a clue to the JUnit test running framework that it should skip it. And sure enough, it said, hey, all your tests passed, but by the way, this Dave student says what is expected. That one was ignored. And it's got a little gray Ghostbusters on it. Okay, so this is cool. I'm going to commit this code. Let's see here. Added and end-to-end test. And I'm going to commit and push that up to GitHub. Oh, one warning. Oh, that's just it's complaining about some code. That's fine. Okay. Okay, well, that was interesting. I'm going to mark that test as implemented. I'm going to just put it in green, I guess. Maybe that's confusing. I'm just going to put it in blue. Like blue background saying that it's implemented. Okay. Let's take a look at test case 3 here. So when I create a student with Dave and those classes and a GPA of ABC, when the student constructor is called, it should get, well, an error message. Okay, well, let's just start implementing this one and see what happens. So let's see here. First of all, we need to come up with a name for this test, which is maybe like GPA is string or something, or GPA is not valid number. So void GPA is not valid number. So I'm going to, actually a lot of this stuff is the same. Oh, I didn't do my red green refactor, did I? Well, I'll come back to it after this. I'll break the rules a little bit. We want to see some more examples. And I will also, hide that. Okay, so GPA is not a valid number. So I want to, again, have Dave operating systems. Well, basically it's my Dave student, except that now I have an ABC as a GPA. So I will copy all of this to create a new Dave. And now my GPA is not going to be 3.64, it'll be ABC. Okay, so I did that, and now it's not compiling because it's saying that, well, it required a double, but it has a string. So what do you think that means for this test case?
Maybe we should be checking that input before it gets to this point. So like as we get it from the command line, maybe it'd be more appropriate to test it in integration instead.
Yeah, I tend to agree. Java is a strongly typed language, and the student constructor declares that the GPA is a double, and you can't assign a string to a double in Java. The compiler won't let you do it, and that's exactly what it's saying. So yeah, this is not a test case that we can express. Nothing wrong with that. As a matter of fact, I think it was really good to brainstorm these things, and it's kind of nice then that the language prevents you from doing that. So I'm going to mark that one in gray to sort of say it's not something I can implement, but maybe it's something that, yeah, I like your idea of saying, hey, is this something that we should maybe consider for the command line where we do express the GPA as a string. Okay, let's look at number 4 here. Oh, and actually I did that one already, so I'll mark it with blue just for completeness. Which blue was it? I have no idea. That's right. Number 4 here. So sending in null, 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 null when the main is called, error message missing arguments. Well, it's interesting. So, okay, actually, let's explore this one a little bit. I like this one, and I'll tell you why. So I'm going to revert these changes. So I don't need that test anymore. Instead, I'm going to create a test which is, let's see here, null arguments, missing arguments error. Well, I would say, what's it going to do? You don't really. So this test case is interesting because it's talking about invoking the main method on a student, which is not really something that you do, right? The main method, and this is a good chance to explain. So the main method is static, which means it's associated, it's a method on the class and not an instance of the class. And so then you don't really invoke static methods against an instance of a class, like a student object. Instead, you invoke it against the class itself. But I think there's a way to take this and actually maybe turn it into something more that we can test here. So like what happens when you create a student and then call its toString method? So we could do this. We could say that the result of calling the toString method with a bunch of, and we can't have a null GPA. So maybe let's give it a valid GPA like that. But like what, yeah, so like if we create this student right here. So null arguments complains. So I don't know exactly what it's going to do yet. So let's create that student. Let's call it nulls. New student. And its name is null, its classes is null, its GPA or whatever, 3.45. You can't have a null there. And its gender is null. Okay. So what should happen when we call the toString method of this student? I think this is saying that it should return the string error message missing arguments. So let's implement that and see what happens. So we're going to assert that when nulls.toString is implemented, then it is equal to, which is that string right there. That's how you would implement that. Is that the behavior we want? So if you create an object with like a student with a null name, what should happen? Yeah. Yeah, ultimately comes from the command line, yeah. Right, so like everything else was invalid, then it would pass them with nulls, yeah. Okay. Okay, right. So I mean, like, that's a good point. So I mean, is it even possible in the logic of the program to pass in a null? Probably not. That doesn't mean we shouldn't protect against it. If maybe there's a different user of the student class in the future that wants to do it. So right, yeah. Okay, so let's say there is a null that gets past the student constructor. What should happen? So do we really end up with a valid student if it's got a null name? Should we even create the object then? Right, should you even be able to create this and get to the point where you can call a toString on it? I kind of think not, right? So, okay, so what should happen instead? So like if I try to create a new student that has a null name, what should happen? So like, yeah, can you have a return a value, throw an exception? I throw an exception, yeah. Okay, well, let's talk about that in our test case then. So like, we don't even get here. So actually, the student constructor is called. So what should happen? What exception should be thrown? And what kind of error message should the exception contain? See at number 5 here, they suggest a legal argument exception. A null pointer exception, maybe? I don't know. Invalid student name exception? Null pointer exception? I think that's okay. It's okay to reuse exceptions. A null pointer exception should be thrown. Well, it is thrown. Okay. Okay, so that gives us some stuff. So a null. So we'll just say student with just like null name throws null pointer exception. Okay. So let's see here. How do we do that? Now, there was an example of how to do this in your project in the airline class, and I think the way you do that is you say assert throws. So assert throws. Oh, Clara, I see you raise your hand. Do you have a question?
Yeah, in the spirit of keeping our unit tests like super granular, would this then follow that for each of these cases, like when classes is null and when gender is null, those would all be separate unit tests?
Yes, yeah, we could do that. As a matter of fact, yeah, that's probably good to have separate unit tests for that, because that way when they fail, I think they probably give you a better error message.
Okay.
So yeah, I'd probably start out that way.
Sure.
Good question, I like that. Okay, so assert throws. Okay, and the first thing that then we give it is the type of exception to throw, and that is going to be null pointer exception dot class. You'll learn about what the dot class means in a little while. Just trust me on this one. And then something called an executable, and an executable is like a line of code that gets invoked using something, and the way to represent it is something called a lambda, which again you'll learn about in a little while, but for right now, all you need to know is that you can say, use that syntax followed by this statement right here. And so basically what this is saying is that, listen, when you call this code, the new student with a bunch of nulls, it should throw a null pointer exception. Okay, and we ran it, and it failed, which is good, because right now we're doing the red part of red-green refactor. So we wrote a unit test that fails. Exactly what we wanted. Great. So now let's make it pass. So how do we make this pass?
Update the student class in the constructor to throw the null pointer exception.
Oh, great, yes. So, okay, so we'll check. Here in our student constructor, if we say if name equals null, throw new null pointer exception. Okay, now let's run it again. Okay, and it passed. Great, now we're green, right? We wrote a failing test, we made it pass, and now let's look for opportunities to refactor. Oh, I see a question. We want to do that in the supers constructor. Oh, interesting. Okay, that's a very good observation. So, and I won't call you out because you sent it to me privately, although I expect everybody can see. That is a very good point. Yeah, because here we send in the name. Maybe we should, and we store the name in the parent class. Should we add it to the super constructor? Can we add it to the super constructor? It turns out we can't, because this is my code, right? This is often a different package, not in, it's often a jar file. It's not code that's part of the project. So in this case, we can't. Now, if I could modify that code, should it? The answer is I don't know. Is it only students that we care about having null names? Can you have a can you have any human with a null name? You can. It's a good question, and one I don't have a hard and fast answer to. but it's definitely one that's worth asking. Good observation. Okay. I do see an opportunity to refactor. I see some duplicate code. Here in these two tests, we probably should have refactored this a couple of cycles ago, but we're getting to it now. Here I am creating two students that have like the same, that are almost the same except for the name. And so what I'm going to do is I'm going to say, listen, instead of having like this duplicate code where I specify the array list and the 0 GPA and it doesn't matter, I want to have a method that creates that. And I'll use the method here, I'll call the method here, and I'll call the method here, and that'll help me get rid of duplicate code. So the way I can do this is I can have IntelliJ help me by highlighting the code that's duplicated. And I use this refactor menu. And I want to say refactor extract method. So this will extract a method from the highlighted code. And it says, great, it creates it right here. And I'm going to call that create student named. And that's going to then it's going to take in one parameter called name, and it's going to return a student with that name. And so I do that, hit return. And IntelliJ then asks me these questions like, well, hey, listen, do you want to change the signature? I almost never do, so I want to keep the original signature. And then I said, wait, I looked at the rest of your code, and I noticed there's another piece of code that looks like it's a duplicate that can be replaced with that same method call. Do you want to replace it? I said, oh, thank you, IntelliJ. That's so nice of you. Yes, of course I do. And I say replace. And so now there, with a couple of quick, easy steps, I took my code and I refactored it so that instead of having this duplicate code of creating the student with this information, it's all created, the student is created in one place, and I call the method in two places. There's a question, or maybe not. Nope, maybe went away. Okay. Sweet. So this is the way red-green refactor works. And normally I would refactor code that's in the test or in the new code that I implemented, and not quite there yet. Yeah. So okay, I think we're good. So let's go back and run all of our tests just to make sure I didn't break anything. I don't think I did, but it always helps to do it. And because they're quick little unit tests, I mean, this takes, what was that? 67 milliseconds to run it, and probably not even 1 second elapsed time. So excellent, we've got some good stuff here. So okay, what do we want our next test to be? We talked about having similar tests for null, for classes of gender. Should we implement those? Let's do that. So I'm just simply going to duplicate this with Command D. And let's see, we want null classes. Throws null pointer exception. So classes is null here. And so, okay, now I'm going to, I wrote a test. I want to watch it fail. So I run it. And it passed. That's not what I expected. Why did this test pass?
The student name is still null, that's why.
The student name is still null. Thank you. Good deal. Okay, so we'll just have a name. Okay. Right. So this is why you always run your test to make sure that it actually fails. Because oops, there was something wrong with my test. And if I just continued on, it would give me a false sense of confidence that my test was accurate and that my code was already implemented. Or that, yeah. So okay, run that. Okay, great. Expected null pointer exception, but nothing was thrown. Okay, now let's go make it green. So now if classes is null, throw new null pointer exception. Okay. Yeah. And again, we're taking baby steps. Okay. That was my red and green. How about refactoring? Do we see an opportunity to refactor? I'm seeing some code duplication here. I want to try something. So what if I take this and I refactor the, oh, sorry, somebody in chat, they probably said the same thing. Can we extract the null test somehow or not because of the changing null argument? By null tests, do you mean the checks for null over here on the left or something about the, okay, I think you're about to do it then. Okay, no. Thanks for calling it out. Yeah, so I'm going to, over here, I've got that code selected. I'm going to say refactor introduce method, and I'm going to call it check or verify validate not null. And I don't know why I keep doing this. Yeah, it's dumb. Original signature. And oh, it didn't replace this other thing. Well, that's fine. So now I'm going to say validate not null classes, and I don't need this code anymore. Oh, look, even where did it? Oh, interesting. Okay, so it says here it was a validate null not null. It took a string, and it's saying, well, you can't pass an array list to the string. Well, that's all right. I'm just going to change. Actually, what does it give me for things? If I do option return, it says wrap using string value, change the parameter, blah, blah, blah. None of those is really what I want to do because it won't work for all of them. So instead, I'm just going to say, make that an object. And now, you know, the name, the parameter here, it's not always going to be a name. So I'm going to refactor and rename the parameter to just be, I don't know, object. And IntelliJ highlighted this in yellow. What did I say? Condition classes equals null is always false. Well, that's true. Because IntelliJ is smart enough to know that if you've gotten to this line of code, then classes is not null. So, okay, tell me how to fix it, IntelliJ. It says remove if statement. Okay. So like I don't need this code anymore. It's basically that the body of that if statement is never going to be invoked. So thank you, IntelliJ. It's very helpful. It tells me these things. So I just refactored this. Now I'm going to run all of my tests again. I'm going to start using keyboard shortcuts because it's faster. So I'm going to say Control Shift F10. Nope, it's Control Command Shift R. Oh, wait, Control Shift R. Yeah, there you go. That will rerun all my tests. Everything passes. Okay, this is good. So I did another red-green refactor. Okay, once more with feeling, we will go through, and now we want to say null gender. Throws no pointer exception. Oops. I will run this one individual test. All right, with the right keyboard shortcut. It passes. Again. Ah, right, okay, because once again, let's see, your classes can't be null, so I need to put it in a new array list. How about now? Good. It failed like I expected with a null pointer exception. Okay, easy peasy. Now we're going to validate that gender is not null. Run this again. Red, green, okay, great. So those tests pass. Let's run all of the tests there. They all pass. Great. Okay, so I did my red. I did my green. Anybody see an opportunity to refactor? Yeah, I don't. Nice. Okay, I think we're good here. So let's commit this code. So let's see here. Validate that parameters to student, etc. are not null. Let me push. Question. Empty array list of classes is also not a valid case. Oh, good call. You are right. Do we have a test case for that? So we just implemented this one. That's good to go. What does that do? Yeah, and so then we have a null. Oh, interesting. Well, you know what? These say that it should be null, but you're right. We don't have one for empty classes. As a matter of fact, let's take a look at this case again, because we say here, this test case says that null is valid, but I think we decided that, oh, that's a good point. Yeah, and Ben said, wait, a student can take 0 classes. So let's figure this out. So what should happen when a student is, has an empty array list? I think it's valid, right? We're taking 0 classes. Yeah. So let's implement number 13 here. Okay. So let's see here. And let's see here. Avoid. The students shouldn't say this class is too much. We're going to take 0 classes. Perhaps I shouldn't. Well, we should have a test class for that. Maybe we should say something different. Students can take 0 classes. Okay. So first we're gonna arrange. We're gonna create an object. And we get a little more screen real estate here. We are going to first have a new student. I think the student's name is Kendra. Yep. Equals new student, and the name is Kendra. They are taking no classes, no array list. They have a GPA of 2.1, and it's that's up here. And cool. And so then we want to say, let's see here. No throw and program execute special case for dialogue. And taking 0 classes. This class is too much work. Well, now let's see here. Some stuff isn't. Well, actually, the says method. The says method is always going to be this class is too much work. So I don't think that's terribly interesting to test, but rather, let's say the toString method, right? The toString method has the number of classes. So, the toString value contains is taking 0 classes. Right, that's what we would expect. So somewhere in the toString, yep, everything else is in there, like the name, but we're just working a very small piece of functionality. Or rather, what's interesting about this test case is that that the toString will contain is taking 0 classes. So I'm not going to have a variable. Let's just do that. Kendra string equals Kendra.toString. And then we're going to assert that Kendra string contains string, which is, oops, I don't want to contains string. This is, oh wow, it's giving me enough preview there. Contains string, what I say is taking 0 classes. Okay, so now let's run this one test, see what happens. I predict what's going to happen. It's going to throw an unsupported operation exception because it's not implemented yet. Cool. Okay. Well, what should we do here? We want to make this pass. What should we do to make this pass? What's the simplest thing we can do to make it pass? Well, the simplest thing we could do. It passes. And what would Uncle Bob say? Well, I would say you're following the rules, right? Because we wrote a failing test. That is valid, right? The test is valid, right? And so, okay. But what should we do next? We have a passing test. Any opportunities for refactoring? Do we see any refactoring opportunities?
Can we generalize student creation into one method wherein we pass the parameters itself, or would it mean like a student constructor itself?
Good question. I think it would basically be the same thing as the student constructor, right?
Yeah.
Yeah. So yeah, I don't think that's terribly interesting.
Yeah.
Interesting, but I think as you know, if we, well, I don't know. Yeah, no, I don't think we're quite there ready with that yet. But keep thinking along those lines. It's a good idea. Do you have a question, something to contribute? Yeah. Okay. Well, so we've done our red, our green, our refactoring. Let's write another test. So what is a test that will fail? Well, it's taking one class. Yeah, I like that. Let's write a test for one class. Student can take one class. So now, here's what we're going to do. We're going to put this into a variable. So we're going to say refactor extract variable. We'll call it classes. And we'll add one class. We'll call it Java. It's a bit more readable here. And now, when Kendra takes, this version of Kendra, it says takes one class. It's taking one class. Now we're going to run it. Aha, it fails, and look how it fails. Okay, so it's saying you've got an assertion error. We expected a string containing is taking one class, which is true. That's what our assert said. We expected it is taking one class, but was it taking 0 classes? Aha, good. We have a red test. Okay, how do we make it pass? Oh, okay. Oh, yeah. Okay. There you go. Yeah. Okay. Right. Just change this. Look at that. Okay. Good. Yeah. Let's run it again. Okay. It's taking one class. Yeah. Great. I know how to play this game. Haha. I figured you out, Uncle Bob. No, let's run all my tests just to make sure that I haven't broken anything. What? Oh no, the other test fails. Now I need to get them to both pass. How will I do that? So okay, so it's over here. We'll actually, well, I don't need to revert it. How do we get this to work? Let's go back to what we had before. So okay, so we sorry. Say more. So create a method. Oh, okay, I like that. Okay, so then yeah, let's see here. Can I do this? Can I say refactor introduce variable? Oh, I can. I'm going to call it number of classes. Okay, and now I am going to say, well, not just always one. Instead, I want to introduce a method that says, well, get number of classes. Oh, look at that intelligence. Okay, and do I want to replace that? But no, what are you talking about? No. Skip. Oh, wow, I was trying to replace like every string. No, I don't want to do that. That's kind of bad. And get number of classes, I don't want this to be a string, I want this to be an int. And so then this is going to be an int. And now instead of number one, string one, I want to do number one, everything compiles. Okay, let me just run my code again just to make sure. I made a bunch of changes. I want to make sure that it's still okay. And okay, student can take 0 classes, failing again. Okay, great. So now I want this to be the number of classes that the student takes. How do I do that? Oh, of the classes. The size of the classes. Okay, great. So classes dot size. Okay, what does it look like? Classes Classes cannot resolve symbol classes. Well, that's true, because no, wait, this appears someplace in this. Classes exist someplace here, right? Yeah, I got classes right here. Oh, but I don't do anything with classes. I validate as not null and I don't store any class. Gotcha. Okay. So now, how do I store a piece of data in this object? Private variable, a field, right? Okay, yeah. Okay, so I'm going to want to store it in a field, and that is, I'm going to say this.classes. Yeah, Ben, you're onto something there too. I want to have a field that I'll call this.classes, meaning that this is a field of the object, which is equal to the class's parameter. It doesn't exist yet, but if I say Alt-Enter, it'll ask me to create it. So yes, please create it. It makes it final because it's only assigned in the constructor, which is actually what I want. And now I'm going to go back to my code. Ah, good. Class. Oh, wait, it's still red. Non-static field classes cannot be referenced from a static context. That is true. So when I created this method, I created static, meaning it was associated with a class on an instance of the class. I want to reference an instance field, so therefore it can't be static. I get rid of that. Ooh, it's much happier now. Great. Okay. I'm going to run my tests again, because I think this might work. And I will demonstrate that it works by running tests. Look at that. They all pass. Sweet. Okay. Excellent. Let's commit that code. And so then let's see here. Include the number of classes in the toString. Methods result. Files commit. Methods. Yay. Gosh, that was awesome seeing all those tests pass, wasn't it? Right? Like, yeah, I did something. And this is what test-driven development's all about, right? Where you take these small little steps. And you know what? I'm sure there are people who are on mute that are just yelling. It's like, I know exactly what to do. You put this anywhere. That is true. And so do I, right? And so do all of you, right? And we can also figure out how to do just the stuff on the left. But when you do the stuff on the right, you know the stuff on the left is correct. And you get, you have a way of validating that at every little step along the way. And so then, let's see here. Was that, I think that was this one that we just implemented. Yay. So we will mark that one off as good. And I think it's time for a break. Let's take a little bit longer of a break because we have a lot more stuff to talk about tonight. So let's take 15 minutes, nice long break. Let your, get yourself re-energized for the rest of class. Okay, we're back. Okay, nice long break. Hope everybody is refreshed and ready to engage. We'll probably, I don't think we'll have time for another break before we go. So it'll be an hour and 10 minutes here towards the end. Okay, so what have we done so far in class? We brainstormed a bunch of scenarios for our project. And I guess I didn't make it explicit, but for the student project. My goal here is to give you a framework that you are free to use for your airline projects. If you, I hope that you're sort of seeing, hey, how can we do something similar? How can I do something similar for my project? I do ask that you brainstorm your test cases on your own, I guess. But yeah, please, if this given when then, and if this page actually, copy this document, use whatever you want to come up with test scenarios to help you understand the boundaries of the program. And then we spent some time implementing some unit tests. Remember, unit tests are really all about the classes that are under test. So we created a bunch of students, and we did that in IntelliJ. And we took lots of small little steps, right? We did the red-green refactor, and we implemented some code there. And the reason that I'm covering testing is because testing is a really important part of the course. It's this is a advanced Java programming. It's more than just writing the code. Is writing good software, and testing is a really essential part of software development. And so, sorry, we're here in week 2. So I want to now I want to talk about some of the some additional requirements for your project. So testing is something that I want you to be able to demonstrate that you can do in this course. And so now, testing is good because it provides feedback, and it's really important that the person who writes the code also be able to test the code. Back when I started, there was a real school of thoughts like, oh no, testing, that's somebody else's job. Well, anybody can contribute to quality, and there are people with really great quality-focused mindsets that when they are partnering with you, your code is so much better. But really, the current thinking, which I think is being shown to be very effective, is that writing, test-driven development and writing tests that validate your code is a really healthy thing. So I want you to be able to experience writing code, and not only be able to experience, I want you to have to experience it, learning. And so as part of your project, you are required to write automated tests that cover, well, a lot of your code. So as part of the project, there is a special Maven command that you can run. When you run the verify phase of your Maven project with --P greater, then what that will do is not only run your tests, but also, so if I go to student here, actually I'll just go to airline, it's probably a better example. When you run this command right here, yeah, you actually probably should clean first. That'll delete all the artifacts, rebuild everything, and run all the tests. It'll put an additional check at the end that validates that all of your that enough of your code was executed by your tests. Meaning that, and this is code coverage, right? So oh, good, and this one failed because it's true. So when you don't have enough of your code coverage, you will you'll get a warning message here saying that only 66% of the code was covered, but I expected a minimum of 75%. The 75% is a good amount of the code. And here again, the best way to get the 75% is to do test-driven development. Because in test-driven development, pretty much all the code that you write, if you only write code because you have a test, well, gosh, you're going to get pretty darn close to 100% coverage. But coverage is not the goal. It's the goal is to have high-quality code that's verifiable. So it's a nice little thing. So this is what's required there. And so when I grade your code, I will run this command with a --P greater, and I will deduct up to 1 point from your project grade if you do not meet the required code coverage. There's some more details here about when you don't have enough code coverage. Actually, maybe I should just show that here. There is a report that's created. Sorry, target site Jacoco. Jacoco is a Java code coverage tool. It tells you things like, hey, yep, you had only 66% of instructions that were hit of code that's executed, and you can dive in to say, oh yeah, here in your fight class, like nothing calls the get departure string, and so therefore it has 0 code coverage, and that's why you only have 40% of your code covered overall. So you can find out what code has been covered, and that's where you should target your tests. But if you're doing test-driven development, you probably won't get there. Oh, also there's a common error that people sometimes see, and sorry, there's a common error. Yeah, there's a common error that people sometimes see, and just do a Maven clean to get rid of that. An important thing that many students often encounter when you're writing your tests, especially when you're testing like your main method, if you call system.exit, that will exit the JVM. If you're calling it from a test, that will exit the test VM, and then your tests will error unexpectedly. And so if you see a message like this when you run Maven, I think you get something similar from IntelliJ. It means that you called system.exit. So you don't need to call system.exit in your code, so just don't bother. I've been talking about testing all night, so I'm not going to read every word of this to you. But those are the expectations for testing. That at least 75% of the JVM instructions, so basically the lines of code, are executed, and that every class, I'm pretty sure I have it here someplace, every class that you write must be exercised by at least one test. Any questions on expectations for testing your projects? Oh, that's in the testing handout, link to on the homepage. The other thing I want to talk about is how to document your projects. So testing is very important, and so is being able to document. Expressing what your code does, and explaining what your code does is helpful to anybody who reads it or anybody who wants to work with it. And so by explaining what your code does, it helps people work with it. So there are two mechanisms that we use to document our code. The first is called a plan of attack. So basically, 3 days before the project is due, which ends up being Sunday afternoon at 5:30, so by then, I would like you to email me a brief description of what your code does and how it does it. And this is meant to primarily, force you to think about your project before it's due. Actually, I found this to be a very effective way of making sure that students don't start at the last minute. But also, it gives you an opportunity to write about your code, to say, hey, how am I going to structure it? How, what are the tasks that I need to do? Again, the planning is an important part of software development. Having the appropriate amount of planning is an important part of software development, and something that I want you to experience in the course, and something I'm going to assess you on. And so POAs are worth 1 point of your project grade. And again, my expectation is like it's 2 to 4 paragraphs. It's written language. It is not code. But tell me how you'll implement your project and sort of like what you're thinking about it. The other part of documentation, this was mentioned earlier, is Java doc comments. So as I think many of you noticed, the student class has these special comments are near certain program elements that start with /*** and end with //. And these are called documentation comments or Java docs. And these always precede a program element like a class or a constructor or a method here. And what these comments are, or what we can do with these comments is run a tool called JavaDoc that will extract them and generate documentation for your source code. And so let's do that. For actually, let's go back to the student. And when we run Maven JavaDoc, this is the JavaDoc goal of the JavaDoc plugin. What this will do is it'll run the JavaDoc tool, and it will look at your source code and extract those JavaDoc comments and create some HTML files that, for that source code. So let's see here, API docs. If we open up the index.html. Here we go, but very simple. Here's all the classes in the package, and we have our student class. So we can click into this, and this generated API documentation has the text from our Java docs. So here we have this class represents a student, and we have this little code block. Well, and here I'll make it a little bigger so everybody can see it. This class represents a student. Similarly, for the constructor, we have the description of the constructor, and then lists all this information about the parameters. These @param tags get translated into information about the parameters. Other cool things is that I have the JavaDoc plugin configured so that it links to the API docs that I have published on my website for the parent class. So here's where you can find all about the human, and if you go to the source code, we'll see that it's a human. Plus, we can link off to the API documentation, the standard API documentation from Oracle's website for like, here's the screen class. And so then this is like a really great thing that Java has. This is really one of the things that enabled Java to have so many people use Java is that it's a well-documented API. And it can be well-documented because it's a standard way of writing API documentation. And again, this is something that I want you to experience. And actually, so the way I will, and so please read up more about Javadoc, how to use the various tags and things like that. And I just used Javadoc, the HTML kind, but you can also, actually, let me just do it clean first. Actually, I didn't need to do that. You can also, when you run with the -p grader option and run Javadoc, this will use it'll generate a special, it'll use a special tool to generate API documentation and just spits it out to standard out. And then this is what I look at when I grade your projects. Are people chatting and I'm not seeing it? Or people deleting their chats or something? That's funny. Because I saw the chat pop up, and yet I don't see it here in the meeting chat. So, is someone trying to tell me something? Think twice if you need help.
No, I was just making a comment about the Java doc saying that Rust has something similar. That's all I said.
Nice.
Yeah.
Rust docs. Sweet. So good. So maybe this is a concept that is familiar to you all. So let's see here. Okay. So then again, one of the points of your project, or rather, I'll run this -p grader Javadoc against your source code, and I've instructed the graders to deduct up to 1 point if the documentation is insufficient. So like if you have lots of methods, or if you have classes that don't have good Java docs, then you'll lose some points. But again, I encourage you to write the API documentation as you write your code. It'll help you better explain what your methods and classes are doing. Okay. And then finally, you remember, you recall from project 1 that there were 2 options: the -print, that'll print the newly added flight, and the -readme. This is what the -readme is all about. So the -readme is part of your program that prints out a textual description of what your project does. So it's more than just command line usage. It is, what the project does, like who you are, and things like that. Your name and the name of the assignment and things like that. It basically is just giving you an opportunity to once again explain some information about your project. And note that when -readme is specified, your program shouldn't do anything else. No error checking, no nothing. Like as you're parsing your command line, you come across -readme, you print the readme, and then you exit. That was it. You return. And again, brief and concise, easy to read textual description of your program. Now, someone had asked about a particular unit test that's related to the README. So for a number of years, I told students, just implement your README as like a big block of text in your source code and just print it out. But I'm like, that's really not the right way to do this. It's really ugly to try to format things in as big strings in source code. The right way to do this is to read a README from a file that's part of your application. And so there's an API called the Resource API, which is mentioned in, I think it's part 2 of the the next week's content. The core API is part 2. That allows you to read what are called resources which are external, basically they're files, but they're bundled in a jar. You can read this resource, like here's a bunch of text, and just print it out. To help you get started with that, there is a test. Sorry, what was that? Is that in Project 1 test? Where is that? Yeah, there you go. README can be read as a resource. The purpose of this test is to show you how to get the readme.txt, which is a file, readme.txt. This is a file that lives in your project. It's off in source main resources because it is a resource file. And basically what you need to do is put your README in here and then use the code that is in the Project 1 test here to get the resource and read each line of it and print it out. So I basically gave you a test of like, here's some code that that will help you implement your README as a resource file. It's optional actually to use a resource file. If you'd rather just have a hard-coded string, that's fine. My experience has been is that boy, this can be kind of hard for Project 1, and that some students struggle with it. So please don't spend too much time trying to get the README to work. What's more important is that you have a README that effectively communicates what your project's all about. Any questions about the documentation requirements? So plan of attack due 3 days before the project is due. Java doc comments on your methods and your classes, and a dash README option to have your program explain what it's doing. Any questions on any of that? Nope. Okay. Now back to the code. Oh, I didn't want to do that. Okay. Once again, our test scenarios. So we got through a couple of these, and I think next week we might do some more. I don't know. I recommend that you start with test scenarios for your classes under test, for your flight, your flight's probably the more interesting one, and for your airline. So get those fleshed out first. Because actually that functionality is pretty straightforward, right? You create a flight, okay, and then you add to the airline. So that's sort of good cutting your teeth on writing unit tests, on taking those really small bites. Anyway, and so working all the logic out there. I want to talk now, I want to spend some time looking at the scenarios for running the command line program. Now, as you'll recall, let's see here, do I have a jar file? Jar. No. Okay, so if I do a Maven verify, compiles the code, runs the unit test, builds the jar file. The jar file, it contains all the class files for the program and any resources like the README. It's all sort of bundled together in one application. It runs the unit tests, also runs the integration test, which we'll talk about shortly. But if everything passes, you'll get a jar file. I will talk about submitting after I introduce Project 2. But it's all there in the README of your Git repository. So I've run Maven verify, and now in the target directory is where all of the created artifacts are. So like your class files and all the compiled code, stuff like that goes in target. We get a student 2023.0.0.jar. So there's a file here, and actually let's just take a look at what's in that file. There's a command called jar, which is like tar. It works with these jar files. That's really all these are. It's a Java archive. It's got a whole bunch of information in it, oh, it has the. Oh, okay, interesting. Oh, right, okay. This jar file has like all of the dependency jar files just all smushed inside it. So it's got a ton of stuff. That's probably what's most interesting. Oh, it's got too much stuff. Where's my stuff? There's not my stuff. Oh, goodness. Really? Where is my student? Student.jar is not in. I must have just missed it. There we go. So here's my student class, and it's got a whole bunch of other stuff too. There's my student class. So now, and this is called an executable jar file, which means that it's got a special, it's got this, where's my manifest? It's got this entry called manifest, which basically says, hey, this jar file, this application has one, has a main entry point, and that will be the main method of the student class. And so that means that when you run the Java virtual machine, give it the -jar file command, and then then give it that, student, give it that jar file, it'll run your main method. Because right now, the main method of the student class, you go down to main, all it does is print missing command line arguments. So ultimately what we want to implement here is all the capabilities described by these test cases. So now I want to be able to automate these tests. And one way to go about this, I suppose, would be to actually, run this command line, write a shell script or something, I don't know, that goes and runs the command line and then captures standard output and standard error and validates that everything's right. But that will require a lot more framework, and that would be heavyweight, and you couldn't run that from JUnit very easily, and I really don't like that. So, but I still want to be able to exercise my main method. I still want to be able to say, hey, listen, I want to implement these test cases. So when I put in 0 arguments, I get a nice error message. And I'd like to be able to do it in JUnit, so I don't have to learn a whole nother testing framework. So, and so then these scenarios, because they're more complex than unit tests, are implemented as integration tests. And so now let's take a look at the integration test for students, and that's in a class called student.it, IT for integration test. I'll put it in the wrong tab, sorry. New JavaScript. Okay. Student IT extends this invoke main test case. An invoke main test case is a class that I wrote that allows you to have automated tests for your main methods without actually invoking a whole JVM. It does a little bit of magic to do things like capture standard output and standard error, and then run the main method itself. But it allows you to write those tests. So for instance, right now, out of the box, it comes with one test method that basically says, invoking the main method with no arguments puts missing arguments to standard error. And the way that we implement that test is that we call this invoke main method. This is inherited from invoke main test case. And we give it the name of the class whose main method we want to invoke. And then we also give it a bunch of arguments. It's a variable length string. And so here we just provide none for 0. And when you call this method, you can call this invoke main method, it returns an object which is called main method result. And main method result allows you to get things like, tell me the text that was written to standard error. Okay, so when you invoke main, get the text that was written to standard error, and then we assert that that text contains missing command line arguments. Because when we ran the program, well, that's exactly what it does, right? It prints out missing command line arguments to standard error. Now, when we run this test, we see that it passes. Oops. Oh, I bet I need to do it clean. Yeah. Yeah, actually, I mentioned this in the handout, in the testing handout. Sometimes you see this error. Maven clean should take care of that. Sometimes IntelliJ and Maven on the command line don't play nicely together. So I'll run the test again. There we go, all happy, and it passed. So now let's take a little while and implement some of these test cases that we had brainstormed. Okay, so now, yeah, let's do the first one here, which is like the end-to-end student. So actually, I'm just going to call this thing, what did I call it over here? If this is the equivalent of, yeah, there you go, Dave student said as expected. I'll just use the same method then. And now, instead of creating a student object, we are going to invoke the main method to do that same work. So let's see here. We're going to say invoke main, and it's going to be student.class. And now it's going to have that big old list of arguments. So all of this good stuff. Now I'm doing it from Java, so it's a little different. A little different than on the than on the command line. But all this input is strings, right? Because what we're sending to the main method is a bunch of strings. Okay, so that is equivalent to doing this. Right? Oh, I'm trying to do the clean. Running maybe package will build the jar file. It won't run the tests. It'll be fine. It won't run the integration tests. Okay, still prints missing command line arguments, which is exactly what you'd expect. Okay, so now I do this big old command line invocation. I want to store the value of this in a variable. So I will say introduce variable. I'm going to call it result. And I'm going to assert that. So here, the result, this is the Dave result. So I want the text written to standard error, and that it is going to contain, standard output. This whole thing right here. And again, this is like my end-to-end ultimate end result. But I think it's, again, I like having this test here so I can figure out how close I am to it and maybe where I need to code next. So run this. It should fail as expected because expected the whole big old string to be written to standard output, but nothing was written to standard output. That's okay because, yeah, I mean, that code doesn't do anything yet. So student here, the main method, it just writes something to standard error, not standard output. Okay, this is good. So anyway, we've got that in our pocket, and that sort of shows ultimately what it is that we want to express. But now let's work on some, let's start by implementing some of these. So let's see here, I've implemented this one. And now, well, let's just go down the list and see where that gets us. So no arguments. Oh, we kind of did this one too. Missing command line arguments to run this program. Please provide the following in order: name, GPA, and one more classes. Actually, that's a way better error message. So let's do that. So, is that done? So I will just now change this error message here. And when I run this, it should fail. And I'll just update the. Now I'm going to make a pass. Again, let's just do the easy thing and just change the error message, knowing that very shortly we will have to support more than 0 arguments. Nice. So now we get that one done too. Oh, interesting. Okay, great. So let's see here. John 3.64 male Java. Gender is invalid. The second argument is gender. To run this program, please provide the following in order. Okay, great. Let's do this one next. And let's just see how it goes. So test. void unknown gender rights. Yeah, let's call it unknown gender. Yeah. Okay, we're going to invoke main again with student.class. And now, what are the arguments? There we are. And this might not be like the smallest test case for this, but it'll work. Okay, I'm going to put this into a variable. I'm going to use the keyboard shortcut this time. I'm just going to call it results. And now I want to assert that result.get text written to standard error contains string. What's the error message? That great thing right there. Oops, a new line. Cool. Okay. So now, here again, when we have this, when we have those arguments, we expect that error message. So we'll run this. Okay, so we expected this error message, the gender isn't valid, but instead we got missing command line arguments because that's all it does. Okay, now we need to start implementing this. So now we need to figure out the how to determine that the gender is invalid. And well, let's see here. Now, yeah, boy, now it's getting a little. Let's see here. The gender is, yeah, second there. I don't know if this is exactly where I want to start though. Yeah, I think I can make it work. So here, the gender is passed in as 3.64, and all these arguments right here are passed into the args array. So then, so like the name will be arg0, and that means that the gender is going to be arg1. And so then we want to say, so we want to validate that the, I basically want to say if not gender is known, is recognized, yeah, we'll say known, gender, then we will print out that big long error. System.error, print line, yes, string. So we'll create this method here. And we're going to keep it false just for the time being, and see what our test is like. Oh yeah, that makes it pass. Okay, well that's all right. Does it pass? We know we'll need to implement this, but we want to write a test first. I'm going to run them all because I'm pretty sure I've broken something else. Oh, look at this. Well, this is interesting. Check this out. So I reran my tests, and my invoking main with no arguments exception gets this uncaught exception main method should not throw exceptions. And like there's a stack trace, which is caused by a different exception, which is an array index out of bounds exception on line 71. I click on that. Oh, and look at that. Okay. So this is on, okay, this is when we invoke main with no arguments. So that means that we're passing it in a 0 length array here. And when we try to get index 0, well, we get an array index out of bounds exception because there is no index 0 because the length of the array is 0. So I think what we need to do is we need to then say if args.length equals 0, that's when we need to issue this error message. And we need to issue the error message and we need to return. Because otherwise, yeah. And let's see here, what's it complaining about here? It's complaining variable name is never used. Yeah, I should probably get rid of that. So again, I don't need it yet. And as a matter of fact, so in TDD, you should not write a line of code that you don't need, right? And the way you know you need it is that it makes a test pass, right? Those are those 3 simple rules. Okay, I've made that change. I want to rerun my tests again while I'm doing that and answer this question. Oh, would it be better to compare args.length doesn't equal 4? Well, ultimately, yes. But I don't know if I need to do that yet. And I'd rather have tests, I'd rather write tests first that force me to add that logic in. So I think this is one of those cases where it's like, right, is that getting ahead of myself? If I know that eventually I want it to be 4? You know, a lot of this is like TDD theater as I'm teaching you how to apply this mindset. And hey, what you do, you know, in the privacy of your own IntelliJ is between, you and your Java compiler. But I'm going to resist the urge to check if length is equal 4. Oh, look, things pass now. Okay, this is cool. So I have a test that does that. Okay. Let's write another one. Oh, you know what? I did a red-green, and what about refactoring? You really see some opportunities to refactor? You know, I like these error messages. I don't like having to have the string in 2 places, right? You know, this way, if I change it in one place, I'll change in the other. It doesn't seem right somehow. So here's what I'm going to do. I'm going to refactor those. So I'm going to introduce what's called a constant for this string. So I'm going to say refactor introduce constant, and this basically 2 things. So this is like missing arguments. And now over here, where's my, here it is. Sorry, what this is ends up being a static field on the class, and it's final, which means it doesn't change, so it's a constant. I'll just reference that constant over here. I'll say student dot missing arguments. And similarly for this thing, which is unknown gender, I'll use a keyboard shortcut this time. And I'll call it unknown gender. Nice. Okay, and then I will student dot unknown gender. Okay. Cool. Okay, I'll run my test again. And see if that refactoring still is valid. I think it will be. Which is good. Refactoring should not change the behavior of your code. Refactorings are supposed to be cosmetic. Things that make the code easier to read or make the code easier to read, right? Or make the code safer, right? Code duplication is can be unsafe because you change logic in one place, you forget the other place, and now all of a sudden things are surprising. This is why it's good to get rid of duplicate code. So now I'm trying to think. Oh, there's one other refactoring I could do, because there is some duplication here when I call invoke main with the student class, but you know what? I'm not gonna do that. So these are integration tests. Integration tests pass in. integration tests basically simulate the command line by passing arguments to your main method and then interrogating standard output and standard error to validate that your main method behaves as it should. So let's see here. First integration tests. I think I want to do one more. We might come back to this in a little bit. Actually, no, I think we should. Let's get kind of late. Okay. Let's talk about project 2 and how to submit your projects. So, in project 1, you wrote the very beginnings of your program, your fundamental flight and airline. Actually, you are writing your fundamental airline and flight classes. And your command line program doesn't do very much, right? It parses the command line, it creates a file object and adds it to an airline, and optionally invokes the toString method and prints it out, a toString method of the flight and prints it out. Very simple stuff on purpose, right? Project 1 is all about making sure you can get your Java code to compile, all about writing tests probably for the first time for many of you. And if you're like, oh, this is so easy, yeah, okay, it might be. It's very simplistic. Project 2, you start doing something a little bit more interesting. So in project 2, you're storing your airline in a text file. And so here is an opportunity to learn how to use Java's I/O facilities and to throw exceptions when input is bad. So here, you're going to continue using your project from project 1. So you don't run a new script to create a new code or whatever. You just augment what you did for project 1. And with some new classes. So there is a text dumper class that implements the airline dumper interface, which takes an airline and dumps its contents, including its flights, to a text file. A text file that can be then read from your text parser. And so a text parser implements airline parser and takes the contents of a file, creates an airline from it and its associated flights, and returns that airline object. So basically what we're doing is persisting our objects to a text file and back again. And the format of the text file is completely up to you. I don't have any specifications for what the text file looks like. In project 4, we'll see that we have something a little different. So you have these 2 new classes, text parser and text dumper. There's also a new main class called project 2, and its main method builds on project 1. So as you can see, you've got the same arguments. Once again, we have arguments and we have options. We have the same arguments as in project 1, but now we have a new option, which is dash text file, which is how you specify what file you want to read and write airline information to. Note that you still support dash print and of course dash readme. And let's see here, and the format of the dates on the command line are the same. The formats of the date in the text file are completely up to you. Oh, notice that you will need to make a change to your pom.xml to reference the project 1 class instead of project 2. So some more notes on the behavior of project 2. If a non-existent text file is provided to your program, this is not an error. Instead, what your program should do is create a new airline object and write its contents, add the flight to it, and add write its contents out to the text file. So please don't issue an error if the file doesn't exist. Otherwise, how's your program going to get off the ground, right? This is bootstrapping the text file. So if it doesn't exist, create a new one. Note that on the command line, any valid file path can be specified for the text file. So it could be from the root file system, it could be relative to the current working directory, it could be a file in a directory several levels down. So don't do a lot of validation on the name of the file, just make sure that its directories exist. Even that is probably not required. There are also no restrictions on the name of the text file. So if any valid file name for the operating system, so for Linux, can be used. And there is no requirement for the suffix or extension. So it doesn't have to be .txt, and it's not, you know, .airline or anything like that. Nope, don't do any of that validation, please. And once again, dates and times are the same as they were for the previous assignment. A couple more things about error handling, and here's where you should be thinking about the test cases that you want to write. So examples of errors that should have graceful exits. If your command line is missing something, or there are extra command line arguments. If the format of the day or time is incorrect. If your text file is bogus, if it doesn't conform, if your text parser isn't able to read it, you should exit gracefully. So please don't, you know, throw a null pointer exception or fall over, or just exit silently. Tell the user something was wrong with the file they specified. And it's also an error if the error line that's given on the command, name of the error line that's given on the command line is different from the one in the text file. That's another scenario that I'd like you to account for. I already talked about this a little bit, so here's a little bit more about the resources API and the README. Sorry. I haven't talked about this before. So resources versus files. The README, when you build your project, exists as a file. And then when you build your project, that file is put inside the jar file. That's what makes it a resource. The files that your command line tool uses are on the file system. Those are on the file system. I have examples of unit tests that test the text parser that read from test files that are resources. For your README, your main code reads the README as a resource. When it comes to reading text files for the airline, those should be read as files. From the command line program, those should be read as files. There are tests that will read them as a resource, and that's nice because that way you can have like a whole bunch of test files that are used to exercise your text parser. But like the main code should still read it from a file. And I think you'll be able to discover that there's a nice way to abstract out where the text is ultimately read from, so that you can keep your code nicely decoupled, and so that you don't have to go to a lot of contortions in order to be able to handle reading a file from a resource versus reading it from the file system. So this is, you can read this in detail, and please feel free to follow up with any questions, either right now if you have them, or on Slack. But this is something that students have learned the hard way. There's an important distinction here between using the resource API for the README and but not using it for the files that are read from the file system. So this is project 2. Is the next phase. It is due in 2 weeks, which, my gosh, is February already. Is that right? Gosh. Right before class. It's worth 7 points. One of those points is the POA. Any questions on project 2? Nope. Okay. Submitting projects. How do I submit my projects? So this is in the README, so we've all got it. Long story short, projects are submitted from the PSU machines, so you need to get your code onto the PSU machines. I recommend using GitHub for that. That'll make sure that you've got all the changes. And the top level directory of the repository has a submit.sh script. It can only be run on the PSU machines. Submit.sh will run some code that I wrote to take your project, bundle up all the source code, and email it off to me. It also does things like it'll run a Maven clean verify with the dash. Sorry, it should be dash p greater, which will make sure that your code compiles and that test pass, and then it has sufficient code coverage. You'll still be able to submit it with things that fail, but I just want to let me do that. Oh, question: what if I ran submit.sh 2 times? That's fine. will grade your most recent submission. Please don't submit like 1,000 times, but multiple times is fine, right? I mean, you submit, on Tuesday night, and on Wednesday, and then Wednesday morning at 3 a.m. you wake up in a cold sweat, realizing that you have a bug. Go fix it and resubmit it, no problem. That being said, yeah, please make sure that your code compiles at least before you submit it. Also, don't, sorry, project 1 is string like comment. Not sure what that means. Or is it a class? Oh, right here. This project 1 is actually just the name of the project that you, so it's the argument to the submit script. It's saying I am submitting project 1. Yeah, it's the name of the project to submit. And so it's like, and I think it will prompt you. I'm pretty sure it tells you what the valid values are. So like project 1, 2, 3, 4, 5, 6, and cones. Yes. Please do not have debugging output. This makes the grader's job difficult to try to figure out what is debugging output and what is real output. And so I've instructed them to take off points if you have miscellaneous debugging output. And here's how you submit. So you just run the submit script with the name of the project. It'll prompt you for to verify that your code is correct, and then if you say yes, sorry, it'll say here's all the stuff I'm submitting. Do you want to submit this? And then if it is what you submit, you'll say yes. The submit program also prompts you to enter like a rough estimate of the number of hours you spent working on the project. This is something that I started doing maybe like a year ago. And this is actually on the request of a student, because the first day they're like, how long do the projects take? And I'm like, I don't know, I don't do the projects. And I'm like, what if I ask people? I'm like, oh yeah, that's a good idea. Gather data, be scientific about it. So, so I added this. And so then I've been collecting that data for a couple of years now. And if you scroll down further, I have a summary of what that data has shown. So for the first project, which are the app classes, I've had a total of 53 students over the years who have responded with how much time. On average, it was 21 hours, and I list the minimum and the maximum. Remember, this is like the one student, so like the most anyone's ever reported is taking is 60 hours. Someone said they got done in 7. But on average, it was 21. The median, which means that half the students took more than 20, half the students took less than 20. 75% of the students took less than 25 hours. So this is all self-reported data. It's meant to sort of give you an idea. So if you think, great, I can bang this out in like 30 minutes, you're probably wrong. Or if you're like, oh gosh, I've been spending, I've spent 18 hours on this already. Is this normal? Yeah, it is. So this is, this information is for your consideration. Do what you will with it. So you can do that. Some notes here about what kinds of files can be submitted. And so there's details there. I'll say this, your POM is not submitted, so you can't modify your POM. So like you can't add new classes, you can't change the configuration of, you can't add new third-party libraries, you can't change the configuration of the plugins. If you really have a need to do this, reach out to me and let me know. This is probably an indication that there's something that I need to be doing. Here again, it's fine to submit multiple times, just don't be excessive about it. And as you might recall from last time, my policy on late work. Nice thing about this is that it there's a timestamp in the submission, so we all know when it was submitted. There's no question of it, being lost in the mail or like, the janitor swept off the floor or something like that. On the submit script, you can provide an optional comment if there's something that you wanted to let me know about. That will be included with your submission, and I'll take a look at it. And also, the submit script will tag your Git repository with a tag that basically indicates, hey, at this revision, here is, this revision of code was submitted at a certain time. This helps you go back in time to figure out, hey, what did you actually submit, and if there was a bug in it. It also can help me debug your code if we're working on it together in office hours or one-off or something. And I have some links off to GitHub documentation to show you how to do all of that. Also, I want to make sure that all of the changes that go into what you submitted are in your GitHub repository. So if you have local changes that haven't been committed yet, it'll fail. The submittal will fail. And then here's just a couple more instructions on how to use the tags. So that's submitting. There's a lot there. But basically what you need to do is, once you have the code working, just run this script and it'll walk you through it all. It'll do some validation. And here again, this is for your benefit, right? You want to know that, like, oh my gosh, my code doesn't compile. Or, oh, hey, I have failing unit tests, right? You want to know that before you submit, not to have to wait for the grader to give you feedback saying, hey, your code didn't compile. Any questions on that? Nope. Okay, a couple more things. So we've been writing tests tonight, and we have been, as we write tests, we run tests, right? This is how we validate that our code works. And so you can run, all of your code here in IntelliJ. As we've seen, when you run Maven Verify, that will run. So we've been working on student. When you run Maven Verify, that will run all of your. That will run like the entire life cycle of your project, right? It'll compile everything. That will run your unit tests or run your integration tests. And this is in doing this sort of like as you're developing and before you commit. That's just really good. But let's say you're contributing to a project that has multiple people who are committing, and there's just a lot more stuff going on. It's really great to have like an independent third party that is verifying that all these changes that are going in work and that the unit tests stay green. This is called continuous integration, which means you are continuously integrating changes into your software, and you are continuously validating that the code's still built and that the tests still pass. So basically, validating that your build is clean. A little while ago, GitHub added the ability to add something called actions. And GitHub actions will take the code from your repository and build it and run the tests for you. And when you see this little green check mark here, it means that your continuous integration tests have passed. And so what happens every time you commit to this repository, the little there are these elves, right? There's a VM that is provisioned someplace, and your code is checked out. Actually, let's just see what we can look at the log here. I build under both Java 17 and Java 19. And so for instance, this is a job that ran when I checked in my code. And what did it do? Well, it set up a Java 17 environment. So it went and it got a JDK, installed it there on this Linux machine that was provisioned. And then it built my Maven project. And because I'm using the wrapper, it just goes and, I've told it to go run this Maven command. And it goes out and runs Maven. So it downloads all of the dependencies. This will probably go on forever. I'll go down to the bottom. Here we go. It's a little bit more interesting. It builds the Java docs. It runs the integration tests, and doesn't run the code coverage. And then everything's happy. And by the way, it builds the top level project. And so this is why it was important to have those submodules here, because let's see if I can find them here. Yep. So because I'm looking at the top level project, when I build this Maven project, it builds all of the submodules also. So when I do a Maven W clean verify from up here, it will build the student project. It'll build the airline project. It'll build the cones project. And because I have the continuous integration server, every time I make a change to my source code, everything gets rebuilt. And if it fails, GitHub will send you an email, perhaps some of you have gotten this email, saying, hey, wait a second, your code isn't compiling anymore, your tests don't run. And this is phenomenal, right? Because you find out about it. Well, GitHub tells you, and because you probably missed it. And so then what this does is it gives you that rapid feedback, and it makes sure that your code builds in a clean room environment, which means that anybody who checks out your code ought to be able to get a clean build. And so then this is just the power of having a build system like Maven, having a source code control system like GitHub, and having all this automation in place to then have the computers do the heavy lifting, so you can focus on something humans are really good at, which is writing code, making decisions, and being creative. And it all comes free and out of the box because of GitHub. Thank you very much, GitHub. So hopefully this provides you with some value and helps you find some bugs in your code, or at least gives you the confidence that everything's working, and so you can go faster. Just wanted to let everybody know about that. You might have seen those emails when things fail, and that's why, very much on purpose, and something that I think is very valuable. Any questions about that? Okay. Well, looking at the clock, we're almost done. We don't have time for more testing, and I think that's fine. We've seen a lot tonight. So we brainstormed lots of test cases for our student project. So so here we are. Let's see here. I think I did get this one done. Let's see here. We did this as a group, and so now we have lots of test cases to implement if we want. And again, I encourage you to use this for your own testing. We then implemented a number of unit tests using just plain old JUnit, and by doing that arrange, act, assert unit tests. We talked about the requirements for this class in terms of testing and documentation. Then we looked at some integration tests. And implemented these test scenarios for the command line using integration tests, where we have a nice framework for very easily invoking the main method with a bunch of string parameters and then validating that the expected things are written to standard error and standard output. And then we covered project 2, learned how to submit that, and talked about continuous integration with GitHub Actions. So lots of stuff covered tonight. But I hope what this does is it orients you towards project 1. So I hope you feel that you at least know how to get started with unit tests and with integration tests, so that you can meet so that you can, first of all, most importantly, learn about and experience writing automated tests, but so also you can have the sufficient code coverage and have that 75% code coverage that's required for the projects. So, anything else before we break? Next week is a little preview of that. We're going to be doing pair programming. So there is a lecture, actually there's a brand new lecture for the first group to experience it, all about the first half, which I'd like you to watch before next week, is all about pair programming. The second part is all about mob programming. We'll do that in a few more weeks. But come prepared to work with someone, might be me, on some pair programming. It's something that I want you to experience, and I hope you enjoy. So we'll do that then. Awesome, thanks everybody. See you next week.